this video, we're doing conceptual derivatives. So let's take a look at our first example. So given that h of x is defined by f of x times g of x, find h prime of 2 if f of 2 is 1, f prime of 2 is negative 2, g of 2 is negative 1, and g prime of 2 is 4. So let's look at what that means. If we want to find h prime of 2, that means find the derivative of h, then plug in a 2. Well, h is two functions being multiplied together, which would be product rule. So let's write out the product rule for h of x is equal to f of x times g of x. Notice that you can write it with the multiplication symbol or without the multiplication symbol. Well, h prime of x would be the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. Now we want to plug in a 2 to our derivative. So h prime of 2, now notice, 2 is the value of x. So we're going to replace every x with a 2. So f of, replace x with a 2. G prime of, replace the x with a 2. Plus g of, replace the x with a 2. Multiply by f prime of, replace the x with a 2. Now let's look up in the directions, and we're going to find numeric values for all of these pieces. F of 2 is defined as 1. So h prime of 2 is equal to 1 multiplied by g prime of 2 is over here and is defined as a 4. So 4 plus g of 2 in the directions is negative 1. So let's replace that with a negative 1 multiplied f prime of 2, and f prime of 2 is negative 2. Well, now it's just simple arithmetic. We have h prime of 2 is equal to 4 plus negative 1 times negative 2 would be positive 2, giving us a value of 6. In our second example, h of x is defined as 3x squared multiplied by f of x. We want to find h prime of negative 1, and we are given some values to help us. So again, h prime of negative 1 means take the derivative, then plug in a negative 1. So h prime of x is equal to, our first function is 3x squared. Our second function is f of x. So we have first function 3x squared multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. So the derivative of 3x squared is 6x. It's important to recognize that some teachers do this in reverse. It is addition, so we can reverse that. Commutative property applies. So now we're going to plug in a negative 1. If I plug in a negative 1 for each x value, I've got 3 times negative 1 squared multiplied by f prime of negative 1 plus f of negative 1 multiplied by 6 times negative 1. H prime of negative 1 is equal to, order of operations, PEMDAS, parentheses exponents, negative 1 squared is 1, multiplied by 3 is 3. In the directions f prime of negative 1 is defined as equaling 1, so multiplied by 1, plus f of negative 1 in the directions tells us 2 multiplied by 6 times negative 1 is a negative 6. So h prime of negative 1 is equal to 3 plus a negative 12 equaling negative 9. In our third example, we notice that h of x is now defined as a quotient rule, one function divided by another function. We are looking for h prime of 1, and we are given several values to assist us. So the first thing we need to do is write out the quotient rule using the values given. Always square the bottom first, so we have g of x squared. Now it's the bottom function multiplied by the derivative of the top minus the top function multiplied by the derivative of the bottom. If we go ahead and plug in h prime of 1, we get g of 1 times f prime of 1 minus f of 1 times g prime of 1 all over g of 1 squared. Let's look for those values in the directions. G of 1 equals 4, so we have a 4 on top, multiply by f prime of 1 is negative 2, so multiply by negative 2, minus f of 1 is 3, multiplied by g prime of 1 is 2. On the bottom, g of 1 squared, well, g of 1 is 4, so we have 4 squared. Let's simplify that. 4 times negative 2 is a negative 8, minus 3 times 2 is 6. 4 squared is 16. That gives us a negative 14 over a 16, which can reduce to negative 7/8.